Hi, very good morning. This is Haribabu from SNS College of Engineering. Belongs to the Computer Design Department, and the subject is about basics of electrical and electronics. Now, the unit 5 is about linear integrated electronics. And the topic 5 is logic gates. Let me see about the logic gates, how it is utilized, how it is being applied. Let me see. Okay, logic gates. What are the logic gates are available and are not NAND nor the basic digital electronic circuit has one or more inputs and has one or more inputs and single output is known as logic gate. Hence, the logic gate are building blocks of any digital system. We can classify these logic gates into the following categories. Example, that is basic gates, music gates, and special gates. So these three gates are we categorized for the logic gates. What is in basic gates? Basic gate is just a basic operation is performed as sum of product of sum. So it is basically and or not gates. Whereas in AND gates, just say about AND gates. What is an AND gate? It's just an two input. It is multiplied or it is actually a logical AND operation. It is done by the symbol dot. Whereas for just see about the AND gate operation, AB is input and Y is output. So actually it is like a multiplication operation. So when it case of 1 into 1 it will be 1, otherwise it will be 0. Uh, Either one among the one value will be 0 and the output will be 0. Its logic gate symbol and its operation as mentioned here. Where AB is input and output is Y as simple representation is given here. Next is about OR gate. An OR gate is an digital circuit. It has two or more input. As well, we say no, it is a AND gate is a multiplication, whereas OR gate is just like an similar to addition operation, but not exact the addition operation. It's just OR operation. The symbol representation is represented and truth table is given, where 0 plus 0 is 0, whereas other than 0 plus 0, the output will be always 1. That is when the output is 1 with 1 or 1 with 0 or 0 with 1 in the output will be 1 is output. Next is about NOT gate. NOT gate is a single input, single output where it is a logical inversion operation. When we given 0 as input, the output will be 1. When 1 is input, 0 will be the output. This is the thing, just see how it is operated, how it is represented by its symbol. Okay. Next is about universal gate. Universal gate is nothing about it will be used as AND gate and OR gate as it can convert the things. It can convert the things into a example AND gate, OR gate, NOT gate. By using NAND gate or NOR gate, we can convert those things. That is a universal gate. So by using NAND gate and NOR gate, we can get an output. We can get an output as our request, not as NAND itself, not as NOR itself. So we can get the output like AND gate output from NAND gate, like this. Okay, that is a universal gate because we can implement Boolean function in the sum of NAND gate alone itself. So using only NAND gate, using only NOR gate, by that we can get an output of AND gate or whatever the gates. Okay, let me see what is a NAND gate truth table, what is a NAND gate symbol, just been represented here. So by the sequence we get an AND gate and NAND gate representation. So AND gate and NAND gate difference is about y is equal to a dot b for AND gate. It is an y equal to a dot b the whole bar. This complement of these things. So here the AND gate symbol is NAND gate symbol is represented as with the AND gate extra the bubble symbol will be represented in the out sequence. So it is represented as NAND gate. NOR gate. Similarly, the NOR gate is inversion of logical OR operation. As previously we said, no, that's a function. So OR gate with the complement of, then it is an NOR gate. So when the sequence is represented as y is equal to a plus b the whole bar, y is equal to a plus b the whole bar. That's about the NOR gate. That is inversion of OR gate. Next about the special gates. What is in special gates? It's about XOR gate and the XNOR gates. Let us see. When XOR and XNOR gates are special gates, these are special cases. That is OR and NOR gates, where there is exclusive OR. That is when 0, 0, the output will be 0, 1, 1, the output will be 0. Whereas when both the sequence is same, the output will be 0. When both the sequence is different, then the output will be 1. This is XOR. By its truth table and its symbol representation, we represent here. Similarly, for XNOR gate, it is just a complement of XOR. Just see 0, 1, 1, 0. So output will be here 1, 0, 0, 1. So this is a representation where here the bubble symbol also represented. So this is the thing will be concluded. By using only NAND gate, we formed then some other gates, and using only NOR gates, we formed this thing. Any queries? Thank you.